Hi, just before this video starts, I wanted to explain what this video is and what this video is not. The primary purpose of this channel is to try to encourage people to DIY, to do it yourself. And especially when you're dealing with things that look really fancy, it can be extremely intimidating. So what this video is designed to be is not an instructional video, though it will be if you sit through the whole thing. What it's really meant to be is a sit with me, learn with me. I want people to be able to see the mistakes I made, the assumptions I made that proved to be wrong, the times when I got it right, the whole process of learning. I want people to be able to see this video and realize you're going to make mistakes like I do in this video, and it's fine. You still get to where you want to be in the end. I really hope this video encourages people to pick up a DIY project, if not a battery-specific project. Now, for those of you who are looking for a more concise instructional video, once this battery is done, I plan to rip it all apart, and by then I'll know what I'm doing and have a really focused, to the point, here's what you need to do to build this battery. So if you want to learn how to build a battery like this, and you find this video is too long, please be patient. Or if it's in the future, the video might already be there. If it is, I'll put a link in the description. Enjoy, hopefully. So now that we have the power supply working, it's time to figure out how to use the charger. So it said to press the switch when booting up, which there's a wheel on the side you can push in on, like a modern mouse wheel. And so that's what I've just done. Select input power supply. They're all the same. 9 volt, 35 amp. Do I have to choose it to edit it? So I pressed and held it to get to this menu. Clearly, I have no idea what I'm doing, but that's okay. That's what we're learning. So here I have a printout, because I'm old-fashioned and I like killing trees, of the manual. I have no clue what I'm doing. Okay, so here it's showing the different chemistries. We're running, well, it's calling it lithium iron phosphate. Charge voltage 3.3 to 3.8, default 3.6. We want 3.65. We're not going to worry about the discharge current. All right, X8 parameter setup. Press on the initial interface to enter the system menu. So down and hold for 1 second. Ah, okay, here we go. Input source settings. We measured this earlier at 12 point something, so I'll set it to 11.5. Current limit. This power supply is good for 12 volt at 65 amps, so we're going to set the current limit to 65 amp. Ah, okay, what did I do wrong? Ah, short click to be able to edit it. Oh, 35 amp is the maximum. Charge power limit. Okay, to calculate this, we take the voltage, which is 3.65 times the amperage, which is 65. Let me do some mathematics to figure out what that is. 3.65 volts times 65 amp is 237 watts? Is that right? That's really low. Okay, setting it to 235 watts. That seems really low, but better to not draw too much power and burn this out, I suppose. I may be wrong in my assumption about this, but there you go. It seems to be right. Note the maximum charger output power is limited by both input voltage and input current. Wattage max equals current max times voltage in. So the current max is 65 amp, the voltage in... Oh wait, it's 12 volts in, not 3... Oh, bollocks, I'm dumb. I was looking at the 3.65 charge current, but it's 12 volts. That's 780 watts. Okay, this makes a lot more sense. 770 is a little bit below. So, okay, all right, that makes a lot more sense. Charge power limit is 770 watts, 12 volts by 65 amp. Okay, save. So I need to figure out how to tell it to output a constant 3.65 volts. There's a balance option only. I wonder if that's what this power option is for, but it only goes to 3.6, not 3.65. That would be a kicker if, after all of this, this charger's not going to do the job for me. Okay, so right now, let's see if we have any voltage on the output pins. We should not. Okay, so I've got nothing on the output pins right now. Keep those pins well apart from one another. And I'm ready to hit the power button if I need to. I want to drop that amperage way down. Yeah, 1 amp just to start. Okay, so at this point I should see 3.6 volts. 3.598. It would be really lovely if it would let me specify 3.65. Voltage is dropping. That's probably bleeding off the internal capacitors. Okay, now it's showing 0 amps. Okay, so what I'm going to be doing here is using these bus bars to link these batteries in parallel. So that means negative to negative to negative to negative, positive to positive to positive to positive. So what I'm going to do is take this connector and I'm going to reuse these studs for my charging leads. Sometimes it would be really nice to have a third arm. I mean, practically, probably not. I don't imagine it would look well in most shirts. So there's the positive. And that is going to link those two positive terminals. We use this to connect the negative. She can build a battery, but she can't put a bolt on a screw. At this point in time, if there was a major difference in charge between any one of these cells, it would start to draw power out of the other batteries. So you don't want to leave them in series for very long. I mean, it doesn't hurt anything per se, but I think it's a bad habit. Oh, I should be wearing my glasses. I'm poking around the terminals. There we go. Properly protected. Well, at least the eyeballs. Barely but a single unga-dunga to tighten them up. What this does, this is a clamp amp meter. We're going to set this to amps. See how right now it's showing the squiggly line down there? That tells me that it's in AC amps, precursor to how I screwed this up. Select, now it's a solid line over a dotted line. That's DC amps. Now you'll also notice it currently thinks that it's reading 0.48, 0.5 amps. That is obviously not true because there's nothing through it. That's just the magnetic field. So I believe I press and hold select. That calibrates it down to 0. I am more than a little nervous about what I'm doing right now, but that's okay. Being nervous helps you stay safe. Turn this on. So I'm in the power option, and I'm going to set the amperage to max amperage, just 30 amp. It's at 3.6 volt. And yes, I should hopefully have not screwed anything up. When I plug that in, it sees the voltage on the battery, connection okay. I don't know if you can see this at all. Zero it out, and I should be able to say start. Are you sure? Yes. Error. Connection check error. Does it not let me check without having the balance leads? Well, let's consult the fine manual. Error 1307. Connection check error. Error description. Connection check error. That is not very useful. So there's a data port that is available for this. I thought it was optional. I'm going to go do some reading. Considering how highly spoken the iCharger X8 is, I'm shocked that I cannot find anywhere the pinout for the balance leads, which seems to be the problem. I found a video by Lithium Solar. He's showing a positive lead, the white lead, going to what I believe is the rightmost connector, and the first black lead going to the positive as the first ground, pin 8 as they call it. But you can see there's the negative going to the or the white going to the positive bus bar, the black going to the negative bus. Yeah, it's very short. It's only shown for a second. So there's the black to the ground, his white to the rightmost pin. That seems to make sense to me. It shows positive on the leftmost pin, and then 8 down to 1 with a negative on the far right pin. So I'm going to try applying the positive rail voltage to the leftmost pin and the negative to the second pin in. Hopefully I don't damage anything. Really not impressed with the labeling or the documentation on this charger. What I have done off camera was, first of all, I moved the ground pin over to the left to give it distance from the positive, so hopefully it'll force the power to be more evenly distributed amongst the 4 cells. And I found a connector I had kicking around that's I think a, I don't know, 2mm pitch connector. Really standard with computer stuff. If you've ever torn apart a computer, it's the standard connectors inside. And they seem to fit well. So my yellow wire is going to my positive rail, my black wire is going to my negative rail. So I'm going to put positive at the bottom, black first pin in. Oh, I hope I don't blow this up. And I'm going to turn this on and see what happens. And if I blow it up, well, at least I catch it for some YouTube drama. Well, that's not a good sign. It didn't power on at all. It would help if I didn't plug it into the output port. Sometimes I wonder how I remember to brush my teeth each night. So again, as I'm fond to say on this channel, being a beginner is okay. Making mistakes is okay. There we go. And it's saying connection error. And the manual doesn't give me any indication on how to resolve this. It's literally connection error. Description, connection error. Balance not needed, remove connection, form balance port. Error 2904. Balance not needed. Balance port error. Does not need balance port, but voltage of balance port is detected. Now it's saying connection okay. Connection error. Good Lord, I wish there was some better documentation for this. Okay, looking at Lithium Solar's current configuration on screen, it seems that he has Lifepo4 charge set, so it could be that I am not doing this properly. Ah, okay, so I've created an additional setup, and here it's asking me how many cells to set. Okay, I'm setting 1 cell, which sets it to 3.7 volts. Okay, so what I've done is I've created a new profile, 1S, because this is in series, so it's 1S 4P. Okay, so I'm setting it to 3.7. I was hoping to set 3.65. 3.7, I guess, is okay enough. It's one-time top balance. We'll get finicky with the preservation of the cells when we're setting up the BMS later. So now I have a new option called Lipo1S2A. So I'm plugging in the balance lead again, selecting it, and I'm getting a connection error. If I say balance, are you sure to run? Oh, connection error because the battery's disconnected. I don't know if this is going to work. Balance port connection error. It would be really lovely if they documented how to connect that. It's showing cell 8. Now, one of the differences is that Lithium Solar is using an X6 and I've got an X8. All right, I'm going to stop the camera and go back to doing some homework. Okay, so I'm experimenting because I can't find anything here. And what I did is I tried connecting negative to negative and positive just to pin 1. Exactly the opposite of what I saw on Lithium Solar's video. But again, he has an X6, I have an X8, so maybe the pinout's in reverse. Right now it's saying connection okay, and I can see that, so here you can see that it's showing cell 1, 3.28 volt. So let's try this now. I'm choosing my Lifepo4 profile. Charge, are you sure? Yes. Oh my God, I think it's working. Okay, so one of the ways I can test is with a clamp amp meter. I don't know if it matters if I do this over the positive or the negative. 2 amps. Now I wonder if there's a way to charge this at higher than 2 amps. So I'm wondering if it reads differently over the positive wire. Nope, it's the same. Doesn't matter which I use. Oh, look at that, it's showing dead nuts on 2 amp, which is what it's showing here. Now 2 amps at 280 amp hour is going to be, well, 280 divided by 2, which is 140. Technically 140 hours to charge these up from 0. That could take a very long time, and this should be able to pump out more power. All right, I've got to poke around a bit. Ah, charge current. Okay, there we go. There's our 30 amps. Haha. All right. Charge cell voltage, 4.2 volts per cell. I want well under that. Oh, it's only going to let me go down to charge cell voltage of 3.85 volts. Okay, now that I'm making some progress, well, first of all, let me turn this off to save batteries. And let me go back to reading the fine manual, now that I've actually made some progress. One step forward. Well, you know what? I'm not going to say 2 steps back because we're actually making progress. I mean, the fact that I haven't blown this up yet, I consider to be fantastic progress. Cutoff voltage is 3.65. The maximum charge current of the battery does not exceed 1C, no problem. We have to stay between 0 and 45C. The house is like 22 degrees, 21 degrees right now, so that's fine. Charge mode, normal balance. Okay. Slow balance, normal balance, fast balance. Not balance. Okay, no, I'll just stick with normal balance. Lipo charge setup. Okay. So I know that I want to cut off at 3.65 volts. Now, why does the iCharger not currently let me go below 2.85? Okay, I have to trust that this is going to stop charging at 3.7 volts. Connection okay. Charge, run program, yes. So it's showing 30 amps now going into the batteries. Confirm, 29 amps are going into it. Now at 30 amps, that is 280 divided by 30, 9.3 hours. So, in theory, if these batteries were utterly discharged, it would take 9.3 hours to bring these cells up. On a per cell basis, there's 4 cells, so that's times 4. So 37 hours to bring 4 cells up from absolutely flat to fully charged again. Why am I getting an exclamation mark 3.85 volt? What's my current voltage across this? It's 3.3 volt. So why am I getting an exclamation mark in the corner? All right, I'm going to abort this. I need to figure out what that 3.85 is. I decided it was time to just call it a night. I couldn't figure out what I was doing wrong, why I was getting the alert. Slept on it, came back and realized I had configured the charger using a lithium polymer instead of lithium iron phosphate. We always refer to these batteries as Lifepo4, Lifepo4. The charger has an LiPo for lithium polymer and an LiFe for lithium iron. I tried to charge using the lithium polymer configuration. Yeah, see how this is Lifepo4? We need to change that. So what we're going to do is long press. We're going to add, oh, type is here. Change that. LiFe, lithium iron. Okay. Cells, we're going to set to 1S. Ah, look at that, 3.3 volts. Capacity, we're probably going to ignore because I bet the highest, yep, the highest isn't enough. We're going to charge at 30 amps. Normal balance. Charge mode, yeah, normal balance. Charge end current off, detect balance on. Current on, detect, end current and detect balance. I don't really know what these mean. Well, the defaults are generally smart, so let's use that. Cell voltage, we're going to use it at 3.6 volts. And we're not going to do anything on advanced because we're not advanced users. All right. Okay, so now we have Life 1S, 30 amp, and 2 amp. Not quite sure why it's doing the 2 amp, but that's okay. So, again, we're going to reconnect this with negative and then positive. All right, this is a little wonky, but so be it. So now we have this connected, we have the BMS connected, the balance leads. Charge, enter, run program, yes. And there it goes. And now we're not getting that alert. So it's a good example of showing why it's important to, if you see something alarming, there's generally a good reason for it. Hopefully you can see that. 29.5, 29.6. We are top balancing, and finally, we are top balancing without an alert. How long is this going to take? I don't know. The only way we can really tell when it's done, it has a 90% here, which might be, the charger might be smart enough to know based on the current voltage how close it is to being charged. We're sitting at 3.418. We're just gonna have to sit here and watch it. Now, because we have a home-built desk power supply, and the manuals for this, understandably from a safety perspective, say don't leave this unsupervised. We're just gonna watch. Obviously, I'm not gonna make you watch. This could take a very long time. So I am going to let this run. I am going to putz around, but always keep this in sight. Keep a feel on the wires, how much power or how much heat is in the wires. So far, everything is a reasonable temperature, and we just wait. Now that I've got this all working, I know it's going to take probably hours, if not potentially days, for all of these batteries to top balance. I don't see a reason doing only 4 at a time. I have plenty of bus bars. I can do 8 at least. So I'm going to stop the charger now, set up an 8P, 8 cells in parallel configuration, move this cable over to the furthest one to spread them out, and then restart the charging. Glasses, safety, safety, safety. At least, you know, safety can be taken too far, arguably, but at the same time, it could also be too lackadaisical and you get yourself hurt. I've already had one dead short. I know how easy it is to make a mistake. Some precautions make sense. Hello, Mr. Wrench, where are you hiding? Oh, it's on the floor. I'm not sure if this is going to be long enough. I should mention that I have bought I think it was a 32 amp DC breaker panel so that I can put a breaker on this positive line for when I'm doing the balancing. Once I'm done filming today, I am turning everything off. I will not be leaving this unattended, but more, I won't be running this for long until I get the breaker. I'm sure you might have seen that video of dude skating down a road, falling backwards and smashing his head off the road, and pieces of his helmet go flying. And he said, I love helmets! It can be annoying when people take safety too seriously, but at the same time, there's a certain amount of safety that's just smart. Okay, I just realized I could have just moved this bus bar over there. I am so smart. I am so damn smart. Huzzah! It's gonna reach. Barely, but it's gonna reach. Having worked in computers for a long time, I've gotten very used to this cycle of getting so incredibly frustrated and feeling defeated, only to eventually figure things out. And in that moment of figuring things out, you get such a sugar rush that all of the frustration suddenly feels like it was worth it. I think that's what an addiction to cocaine must be like. We should now be able to restart this. Charge, are you sure? Yes. And there we go. And again, I'm going to double check, and now check the cable. Let's see if I can do this over this one. 29.68. We're top balancing half the battery. Again, I have no idea how long this is going to take. I'm going to stop this very shortly and wait until I can get a breaker to put this cable through. It's happening. It's working. I'm so happy. Just a really brief update. The charger's been running for, I think we're in the 3rd day now. I turn it off when I'm not either sleeping or not at home. So it's not been continuous for 3 days. I've added a 32 amp DC breaker. The charger puts out 30 amps, so it's just a little bit higher than what the charger can push, just for a little extra safety. And you can see that after all of this time, let's see if we get that a bit closer. After all this time, it's now pushing out the full 3.6 volts, and the battery voltage is finally starting to rise. Again, lithium iron phosphate has a really flat charge and discharge voltage curve. So I think we might actually be getting towards the top balance of these first 8 cells. More later. Put 400 amps into it yesterday. I don't know if that's focusing properly. Got another 110 amps into it so far today. I don't know how long this is going to take, but it's being recorded to an SD card, so once this bank is done, I'll probably graph it and finish the video and then start charging the second bank. I have an idea I'm going to talk about on what I could have done differently to have made this go a lot faster. So this has been interesting. After I don't know how many amp hours have gone into these batteries, I'll know when I pull the SD card. The charge voltage jumped quite a bit to like 3.8 volts at one point. And you can see the battery voltage now is sitting at 3.6 volts. It started climbing relatively quickly, and look at the amperage just dropping off. I think after all of this time, we might finally have finished top balancing these damn batteries. So the balance, I suspect some people might think that the balance leads might not be important because it's reading the voltage from the output pins. But the output voltage is clearly different from the pack voltage. As soon as it hit 3.600, look at the amperage just dropping off. Ladies, gents, and others, I think after an absolutely stupid amount of time, the first half of this pack is top balanced. Wow. I'm... Oh, I've been stressing about this so much. Every time I step out of the house, when I go to bed, anytime I can't actively monitor this charging setup, I've turned it off. It is currently Friday evening at 7:15, and I have been running this since the weekend. It was starting to feel like it would never end. Look at that amperage just fall off. Oh, what a beautiful thing. So I think what I'm going to do is I'm going to let this drop off, and then I'm going to switch out the balance. I'm going to switch the bus bars over to the second bank. I'm going to start that one balancing. These cells will take a little while to settle out. What I mean by settle out is that when the voltage, right now it's showing 3.6 volts. If I turn this off, you're going to watch the voltage just fall. And that's fine, that's expected. It's still sitting at 5 amps. So that might mean that one of these cells is still a little... Oh, the fan just turned off. One of these cells might be a little bit lower than the rest. I wonder if I should balance... I wonder if I should balance the other bank of 8 and then come back and one cell at a time connect this one battery, one battery, one battery, one battery, and bring each of them up so that each one is individually showing 3.60 volts and the amperage drops off. It's holding at 5 amps. Something is... Oh! As soon as I open my big fat mouth, look at the amperage fall. 3 amps. Done! Woohoo! Oh, ladies and gentlemen, I think we have, and others. Gotta remember my NB siblings here. Half of it's done. Okay, before I start the next one, I'm gonna pull the SD card out and see if I can graph this. I'm really curious to see what this looked like. Oh yeah, this is awesome. Okay, more later. Editing Maddie here. So it turned out it took 50.2 hours and it took just shy of 1500 amp hours to charge the battery up. What you're looking at here with the blue line, that's the charger output voltage. You can see there's that where I say playing with settings, where I was playing with the settings. The other thing you'll notice is that you'll see numerous dips between where the blue line and the red line both dip at the same time. That's every time I turned off the charger and turned it back on. When you stop charging the lithium iron phosphate batteries, the voltage drops off. So when you start the charger back up, the voltage has to ramp back up. And you can see the charger is matching the pack voltage. It surprisingly well. What you're also seeing right at the very end is where it got up over 3.8 volts. That's where I got really nervous and I kept turning the charger off because I was worried I was doing something wrong. Turned out I wasn't. As you can see with the red line is the pack voltage. Right at the very end, you can see it shoot up, and as soon as it hits 3.6, the charging stops. That little section at the beginning where there is no red line, that's because I forgot to plug in the balance leads, so I wasn't able to monitor the pack voltage. And in this chart, what we're seeing is the charge amp hour going into the pack. It's zoomed in right towards the end of the charge cycle. So you can see it starts at 2950 seconds. And you can see how as soon as the pack hit 3.600 volts, the charge amperage just fell off. That's because the battery pack it wasn't absorbing any more power anymore. So we are now finally, oh, Lynx wants to say hi. Hi, Lynx. Now get back down, please. Oh, okay, well, don't then. Kitties. I really wish now in hindsight I had left it as a 48 cell, as a 48 volt 16 series cell and ran the Victron charger. The Victron Quattro could charge at, I think, 51.2 volts at 70 amps. I didn't realize how low these batteries were. If I had have left them as a single battery, 48 volt battery, run the Victron charger, I could have brought them up most of the way, stopped the charger, and then turned it into a pair of, 1S8P batteries, and used this 30 amp charger to bring it up rest of the way. Because I didn't do that, and because half of them are already done, I've just got to sit and deal with how long this is going to take. I had really hoped by the end of this video to be able to show you guys, oh, look at this, it's fully top balanced, let's assemble it into a battery and be off to the races. It's not how it works out. That's okay. That's part of being new to something, is you realize after the fact, oh, if I had only just done it this way, it would have been so much better. That's all right. That's part of learning. We have to be patient. So I'm going to end this video here. Sometime over the next week, this will finish balancing out the second pack, and we'll finally turn it into a finished battery, and we'll get the BMS fired up, and we'll start talking to it and start playing with the Quattro. That beautiful Quattro has been sitting in my basement for months, waiting to be tickled. It's time to tickle it, I think. I'm the Digital Mermaid. See you later.